this video, we are going to explore many multiple objective questions that is based on these concepts. The first concept we will deal with order and the degree of differential equation. Then we will work it out on the type of a differential equation, whether the differential equation is homogeneous, non-homogeneous, linear, non-linear. After the normal differential equation, under what condition that is normal, we know that, but we need to identify on which interval the given differential equation is normal. Next, we will deal with the concept of linear independent and dependent function. For this, we will use the concept of Wronskian. At last, I will give you one example that is based on the Abel's formula, how we can use this Abel's formula in order to calculate the Wronskians. So beginning with the first type of a concept, that is the order and the degree of differential equation. So now what do you mean by order and degree? Order means that is the highest derivative of the differential equation, and the degree means whatever the highest derivative we have in that case, take its power that represents the degree of differential equation. But for that we need to convert the differential equation into the polynomial. Let's explore with the help of multiple choice questions. Here we have a first question. So according to this question, we need to identify what is the degree of this differential equation. Out of these, one correct option is there. Firstly, we will simplify this differential equation because it is not in a polynomial form. Let's write its simplified form. So firstly, I am writing dy by dx as the y prime. So we have 2 is equal to x y prime plus x by y prime. That is the first order derivative. Now simplify this. So we have 2 times of first order derivative, that is equal to x first order derivative square plus x. So this is equal to x into first order derivative square minus 2 times of first order derivative is equal to x. So this is the differential equation, that is the first order. So first order derivative is occurring 2 times. Here is a power as 2, here is a power 1. So we take highest power. And the highest power is 2. So in this case, the degree of the differential equation is 2. Moving to the next question. Question is the degree of the differential equation. This is what? So again we can check this one. There is a second order derivative over here and its power is 1. So we can directly say that the degree of this differential equation is 1. So where is the one option? That is in a B case. Next question is the differential equation this is of the order what? So we need to observe this differential equation. So in this case it is a x square y derivative how many times? M times, and its power is p plus x into m minus 1 times derivative of y with respect to x whose power is m square. So in this case, what is its order? Order means highest order derivative. If you observe these two terms, in this case, it has the derivative m time and here it is a m minus 1 time. So which one is the maximum one? That is m. So it means in this case, the order of this differential equation is m. And suppose if the question is what is its degree? So degree means we need to take the highest order derivative power. So what is the power in this case? That is a p. So in case the question is degree form, so in that case the answer is p. Next question is the order and the degree of this differential equations are what? And that is written in a respectively word. Respectively means first we need to write the order and then we need to write the degree. So first we need to check highest order derivative in this case. So highest order derivative is 2. Now before finding the degree, make sure first simplify this form because there is a fraction power over here. And we need to convert this into the polynomial. What we can do, this is 1 by 4. So we can take power 4 on both sides. Taking power 4 on both sides, we have of this form x plus first order derivative with respect to x, its square. We can just observe this term because in this case the highest order derivative is 2 and what is its power? Its power is 4. So where is this option where degree is 4 and order is 2? So we need this type of a form 2 comma 4, and that is present in the option 4. In this case, fourth option is correct. Next question, the order and the degree of this differential equation. So again we have this fraction form over here. So we need to remove this case. So what we can do, we can write this as 1 plus first order derivative power 3 by 2. This is equal to minus second order derivative. Next, take the square on both sides so that we can remove 1 by 2 from here. So when you take the squaring on both sides, we have 1 plus first order derivative 3 by 2 its square is equal to minus second order derivative its square. Now this 2 will get cancelled with this one. So we have 1 plus first order derivative power 3, that is equal to second order derivative power 2. That minus square is equal to positive. Now from here we need to find order first and then degree. So what is the order in this case? Highest order derivative, that is the 2. So order in this case is 2. Now we need to find its degree. Degree means the power of highest order derivative, that is again 2. So we need this answer 2 comma 2, and that is present in a C option. Next question is, what is the degree of this differential equation? So this is a second order derivative plus twice of x raised to power 5. So first find its order. So order in this case is highest order derivative, that is 2. What is its power? Power is 1. So in this case the degree is 1. So let's have a next last question for the degree and order. So in this case we need to find its degree as well as order. So you can observe this is already in a polynomial form. So second order derivative is there with respect to t, and here it is a first order derivative with respect to t power 3. So there's a misprinting. Here it is a t variable. What is the order? Order means highest order derivative. Highest order derivative is 2. So order in this case is 2. What is its degree? Now what is its power? Power means just the highest order derivative power, that is 1. Do not take this as the degree. We just need to observe the highest order derivative. So in this case the degree is 1. So this is in the option B. So now we will deal with a certain type of a differential equation. We need to identify whether that is a homogeneous, non-homogeneous, linear, non-linear, or a normal. So homogeneous case means if we have a differential equation in terms of dependent variable and its derivative, but there exists no independent term of the independent variable. Non-homogeneous means definitely there exists a one term that is the independent from the dependent variable and its derivative. Linear means the degree of dependent and its derivatives are 1 and they are not in a product form, and even there is a no non-linear function of the dependent variable. And if such things are not applicable, in that case that differential equation is non-linear. And the normal means if we are saying the coefficient of dependent and its derivatives are continuous along with your non-homogeneous function, make sure it is also continuous on a given interval, and the leading coefficient means the highest order derivative coefficient is not is equal to 0 for any value of x. So for more details on this concept, you can refer the previous videos. So beginning with the question, which one is the differential equation with variable coefficient? So here we just need to observe the coefficient of the dependent variable. Here dependent variable is y and its derivative is there and second order derivative is there. What is the coefficient of second order derivative? That is the 1. What is the coefficient of first order derivative? Minus 5. Coefficient of y, that is x. Now we have a variable coefficient in this case. It means this is a differential equation with a variable coefficient. Now what about the other? So in this case second order derivative, it has a coefficient in terms of independent variable, that is x. So again, this is a differential equation with the variable coefficient. Now what about in this case? So second order derivative coefficient is constant, first order derivative coefficient is constant, dependent variable coefficient is a constant. We just need to observe the coefficient of dependent variable along with its derivative. There's no need to observe the non-homogeneous function. This is a non-homogeneous function. So in this case, all the coefficient of y and its derivatives are constant. So this is not a differential equation with a variable coefficient. In short, this is a differential equation with a constant coefficient. So according to this, A and B are the differential equation with the variable coefficient. So answer in this case is C. Next is the differential equation is linear homogeneous differential equation, linear non-homogeneous differential equation, non-linear homogeneous differential equation, or non-linear non-homogeneous differential equation. So we need to observe this case. So according to this one, first thing, dependent variable. Dependent variable is y, first order derivative, then its second order derivative. Now there exists a one term that is not depending upon y and its derivative. So we can take that on the right hand side. So we can write this as second order derivative minus 5 times our first order derivative plus 6y is equal to 2. Now answer this differential equation whether this is a homogeneous or a non-homogeneous. So non-homogeneous because of this term. So clearly A and C is incorrect option because it is saying for the homogeneous differential equation. Now whether this is a linear, for linear make sure their power is 1, yes. Second condition is whether they are in a product form, no they are entirely in a separate form. The third point is whether there exists any non-linear function in terms of y and its derivative. No. So it means clearly this is a linearly non-homogeneous differential equation and the answer in this case is B. Next question is the second order linear differential equation. This one with constant coefficient is homogeneous as well as non-homogeneous. Homogeneous, third option is neither homogeneous nor non-homogeneous, and the fourth option is non-homogeneous. Means we just need to figure out whether there exists any additional term except y. So we can check it. Y is there, derivative form is there, second order derivative is there, and on the right hand side there exists no such term over here in terms of x. So it means it is a 0. Therefore, we can say that it is a homogeneous differential equation with a constant coefficient. Next topic is a normal differential equation. So when we say the second order differential equation is normal, let's take a small recap of this one. So for that we are saying collect the coefficients of dependent variable and its derivative as well as your right hand side function, non-homogeneous function. Make sure they all are the continuous functions on a given interval I. Second condition for this case is the leading coefficient means second order derivative. Highest order derivative coefficient not is equal to 0 for any x. So it should not be is equal to 0 for any value of x in the interval. So if these two conditions are fulfilled, then we will say that the differential equation is normal on the interval I. Moving towards the first MCQ question on this case, so differential equation this for n integer is normal on every subinterval I of the open interval from here. So we need to identify this differential equation is normal on which interval. So first we need to collect the coefficient. So starting a naught is equal to 1 minus x square. Start with the second condition. Make sure this number is not is equal to 0. So when it is getting a 0, it is getting a 0 when x is equal to 1 and minus 1. So we don't need these 2 points in our interval because we want a normal differential equation. So minus 1 is a part of this one as well as a 1 is a part of this one. Clearly this is not the answer. Now if you observe the B option, in this case minus 1 is a part of this one. Again this is not the option. If you observe the D option, Again, minus 1 as well as a 1 is a part of this one. So for this interval, again it is not a normal. So we have only one option. The answer is C. Next question is find the interval on which this differential equation is normal. So collect the coefficients. So coefficients are a1 is a0 is equal to 1 plus x square, a1 is equal to 2x, a2x is equal to 6, and your right hand side function is equal to 0. Now all these are the polynomial and they are continuous for every value of x belongs to the set of real number. Now we need to observe this number should not be is equal to 0. So we can check that when it is getting a 0, this is getting a 0 when x is equal to plus minus iota. And when we are working on this one, we are just dealing with the real numbers. So this is not the part of any of the interval. So we can say that this quantity is never be is equal to 0. So we are getting a maximum range as the set of real number full. So answer is B. Next question is this differential equation is normal at every real point or normal only at x is equal to 0 or normal at x is equal to 1 or normal only at x is equal to plus minus 1. So we need to check the interval for which it is getting a normal. So its coefficient is 1. We have no problem in this case. It is not is equal to 0 even it is a continuous. What about this one? X minus 1 with a negative sign. Is this function is continuous? Yes. There is no need to check whether this is not is equal to 0 or getting a 0 because we just need to figure out for the highest order derivative coefficient that is 1 and it can never be is equal to 0. Next coefficient of y is minus 1. Again it is continuous. And this point is non-homogeneous function. So if you take on the right hand side, we have this is equal to 1. So this function is always continuous. So we can say that this differential equation is normal for every real number. Next question is if this differential equation is given to you and that is a normal over the interval I, and then what is the value of that interval? So first we will simplify this form. So we can write this as equal to first order derivative is equal to 3y by x. This is equal to x into first order derivative is equal to 3y. This is further is equal to x times of first order derivative minus 3y is equal to 0. Now according to this leading coefficient is x, that is a first order derivative coefficient. Next coefficient is minus 3. Right hand side function is 0. Now we need all these functions are continuous. Yes, they are the continuous for every real number. But there is a second condition that starting point leading coefficient is not is equal to 0. So we need x should not be is equal to 0. So when it is getting a 0? When x is equal to 0. So means the given differential equation is a normal for every real number except 0. This was the original one. So whether this is given in the options, so you can check it. 0 is a part of this. So it means this is not the option. Again 0 is a part of this one. Again it is not the option. 0 is a part of this one. This is not the answer. Now here 0 is not the part of this interval. It means on this case or we can say that on this interval this differential equation is normal. Next question is on which interval this differential equation is normal. We need to collect the coefficient. Highest order derivative coefficient is 1 and it is not is equal to 0. And it is also continuous. This is also continuous because it is a constant. Constant is always continuous. What about this one? In this case again we are getting a constant and it is also continuous. Now non-homogeneous function is there log of 9 minus x square when it is a continuous. This is a continuous when whatever the angle mentioned over here that is greater than 0. Now this quantity is greater than 0 when? So we need to observe. So what we can do in the next step, we can write this as a 3 minus x, 3 plus x greater than 0. So now this is getting a 0 for 2 points, that is minus 3 and 3. So now check on this side minus infinity to minus 3 whether this quantity is positive or a negative. So how you can check that? You can take any number from this interval. Let's take minus 10. When you take minus 10, so this quantity is positive, into 3 minus 10. This quantity is negative. Positive negative is always negative. So on this case, we are getting the answer as a negative. From the minus 3 to 3, take any point. Take x is equal to 0. So when you take x is equal to 0, so this is a 3, this is again 3, always greater than 0. So it means in this case, we always get answer as a positive. From 3 to infinity, let's take it as a 4. So when you take 4 as over here, so 3 minus 4 is minus 1. 3 plus 4 is 7. This quantity is always negative. So on this case, we are getting the answer as a negative. So overall, we need this quantity must be greater than 0 and this is greater than 0 only in this interval. Make sure we are not taking the end point because we need strictly greater than 0, not is equal to 0. So in this case, the interval is minus 3 to 3. Next concept is whether the functions are linear independent and dependent. For that we are using a Wronskian that is calculated by this form. This is the determinant of the functions, then getting its first order derivative, then its second order derivative. Make sure we have the square matrix when we are taking the Wronskians because otherwise we cannot evaluate the determinant. Keep one result in a mind that if the Wronskian is not is equal to 0, the functions are linearly independent, and if the functions are linearly independent, in that case the Wronskian is not is equal to 0. Let's take this example. So consider y1 as a sine 2x, y2 as a cos 2x, and y3 as the 1. These are the three functions. So we need to find which of the following is the true. Means y1, y2, y3 functions are linearly dependent for any value of x, or they are the linear independent for any value of x, or they are dependent for x is equal to 0, or the option is none of these. So what we can do, we can find its Wronskian. So we can directly write the function. First function as a sine 2x, second function as a cos 2x, third function as a 1. Now take their derivative. Derivative of sine 2x is 2 times of cos 2x, and the derivative of cos 2x is minus 2 sine 2x. What is the derivative of 1? 0. Now take its derivative further, that is the cos 2x derivative is minus 2 sine 2x. So 1, 2 is already there, so it is getting a minus 4 sine 2x. Take its further derivative, that is the minus 4 cos 2x. Its further derivative is 0. So we can take the determinant from this side. So we have this is equal to 1 times of cos of 2x into minus 4 times of cos of 2x, then minus 4 sine 2x into minus 2 sine 2x. So this is equal to minus 8 cos square 2x. This is minus minus positive. 4 into 2 is 8 and this term is square and one negative sign is outside. So we can write negative of 8 sine square 2x. So taking minus 8 outside, we have this form. So cos square theta plus sine square theta is 1 and their angles are same. So we can put this value is equal to 1. So we have minus 8 over here. So Wronskian is not is equal to 0. It means these three functions are linearly independent for any real value of x. Next question is, Which of the following functions are linearly independent? So these four options are given to you. You need to judge which of these functions are linearly independent. Since the interval is not given to you, so we will assume that we need to figure out whether the functions are linearly independent on set of real numbers or not. So we will take the interval as a journal, that is a set of real number. So we will not evaluate the Wronskian in this case directly. First observe the option. So if we have a same type of a form over here, that is sin x, sin 2x, sin 3x. Observe that for any value of x is that function is same. Suppose if I take x is equal to 0. On that this function is 0. Second function is again 0. Third function is again getting a 0. So now we can say that for any real number, suppose in this case we have taken 0, if the functions are same, or we can say that after substituting that point we are getting a same function, then we cannot say that the functions are linearly independent on set of real number. Now what about the C option? So look at on this case. Log x is defined when x is greater than 0. Only in that case this is defined. So now for what value of x it is getting a 0? That is the 1. So if I take x is equal to 1 and that is a part of a real number, log 1 is 0. Log 1 square again 0. Log 1 cube again 0. So in this case the definitely Wronskian is getting a 0 for x is equal to 1. So it means we can say that these functions are not linearly independent. So from here we can directly discard the option A and C. Just figure out for the option B. Because if you take 0, we have 0, 3, 2. If you take 1, we have 2, 9, 5. This type of a numbers we have. We are never say that they are getting the same numbers or we are getting same quantities. So in this case, we can find the Wronskian. So Wronskian in this case is 2x, 6x plus 3, 3x plus 2. Now, its derivative is 2, its derivative is 6, its derivative is 3. What is its further derivative? 0, 0, 0. So all are getting a 0 at the last row. And what is the determinant in this case? That is 0. So if the determinant is 0, we can say that the functions are linearly dependent. So again, this is not a linearly independent. So final answer in this case is the none of these. Next question is, the functions are linearly independent if, what is the condition for the Wronskian? That is not is equal to 0. Next question is, the function these are linearly dependent, both A and B or none of these. So we have recently evaluated Wronskian. So Wronskian in this case is 2x, 6x plus 3, 3x plus 2. So we need a 3 by 3 matrix because three functions are there. Its derivative is 2, derivative is 6, its derivative is 3, and the last row is 0. Its further derivative 0, its further derivative is 0. So determinant in this case is clearly is equal to 0. If the Wronskian is equal to 0, we can say that the functions are linearly dependent. Next question is, on any interval I not containing 0, means 0 is not the part of that one, the function x, x square, x cube are linear independent, dependent, neither linear independent nor dependent, or none of these. So we will find the Wronskian in this case. So we have first function as x, next function as x square, then x cube. Its derivative is 1, its further derivative is 0. Its derivative is 2x, its further derivative is 2. Its derivative is 3x square and its further derivative is 6 into x. Its determinant is equal to x times of 12x square minus 3 into 2, that is 6x square, minus x square into 6x minus 0, plus x cube into 2 minus 0. Simplify this, we have this is equal to 6x square into x, that is the 6x cube, minus x square into 6x is 6 into x cube, plus twice of x cube. So this is further is equal to twice of x cube. So this is the value of Wronskian. So Wronskian in this case is getting as a x cube. So we want a linearly independent function if, so in that case the Wronskian should not be is equal to 0, and it is getting a 0 only for x is equal to 0. And even in the question it is given that it is not containing a 0. So it means this quantity cannot be is equal to 0 because we are not taking x is equal to 0. So clearly we can say that the Wronskian is not is equal to 0 for any value of x, and therefore the functions are linearly independent. Next question is Wronskian of this function. So first we need to take these functions. So over here if you observe that for the first option we have sine 2x, but the next term is cos 2x, but we need a cos x. So clearly this is not the option. What about this one? Sine 2x, cos 2x. Cos 2x is not the part of this one. So again, this is not the answer. D option, 1. So 1 is not the function in this case. So we are not taking 1 in the given question. So it means this is incorrect. So last option we have B. Next question is, let y1, y2 be the linear independent solution of this differential equation. Then the Wronskian in this case is what? So whenever we have the differential equation and Wronskian is given in the form of constant, we can use direct Abel's formula. So according to the Abel's formula, the Wronskian of the second order differential equation is written as e raised to power minus a1 upon a naught into dx, where a1 is coefficient of first order derivative and a naught is the coefficient of second order derivative. That is a constant multiple of this. So this is equal to c times, that is some constant, into e raised to power minus, what is the value of a1? That is the first order derivative coefficient, minus 4. Do not say that 4. Take negative sign over here. Minus 4 divided by coefficient of second order derivative, that is the 1. Integrate with respect to x. So minus minus will be positive. So constant times of e raised to power, integration of 4 is 4x. So in this case the Wronskian is of the forms constant into e raised to power 4x, and that is available in option C. Next question is the Wronskian of these three functions. So it is calculated as determinant of x, x square, x cube. So three functions are there. So 3 by 3 matrix is there. What is its derivative? 1. Further derivative 0. Its derivative is 2x. Its further derivative is 2. Derivative of x cube, 3x square. Its derivative is 6x. We have already calculated the Wronskian of this one. That is in the example. This, in this case the Wronskian is equal to 2x cube. So we can write this is equal to 2x cube, and the final answer is A option. Next question is, what is the absolute value of the Wronskian for this case? So first let's calculate the Wronskian. Wronskian in this case is determinant of cos x, sin x. We are taking the two functions. Its matrix order is 2 by 2. Cos x derivative is minus sin x. Derivative of sin x is cos of x. Take its determinant, it is a cos square x, minus minus will be plus sine square x, that is equal to 1. Now the point is, what do we mean by absolute value? Absolute means we need to take the modulus value of the Wronskians. So what is the mod of 1? That is equal to 1. So if the number is a negative, answer should be in a positive. This is the meaning of absolute value, and in this case answer is A option. Next question is, what is the Wronskian of 1 and e raised to power x? So two functions are given to you. So directly calculate that. Determinant of 1 and e raised to power x functions are 1 e raised to power x, its derivative is 0, its derivative is e raised to power x. What is the determinant in this case? That is e raised to power x. So answer in this case is B.